is we want to use that interquartile range to help us determine if outliers are present. Until now, we've just been looking at our graph and we say that one looks unusual. I think it might be an outlier. Or that one looks unusual. I think it might be an outlier. Well, now we're actually going to determine for sure if it is or is not an outlier. So we do a multitude of things. First, we calculate that interquartile range. So we take the Q3 minus Q1. And that gives us the spread of that middle 50%. We multiply that by 1.5 to get an amount. This amount represents how far out from Q3 and Q1 we're willing to go. Because anything beyond that distance from Q3 and Q1, we're going to consider to be unusual enough to be an outlier. Okay? So we take our Q3 minus Q1, which we already computed to be 27.5. Okay, we got that on our previous slide. Oh, got my pen. We multiply that by 1.5. So we get this amount. We're saying anything that is more than 41.25 minutes above Q3, or anything that is more than 41.25 minutes below Q1 is considered unusual. Okay? I once Googled to find out why 1.5 IQRs, and I got an answer and I've since forgotten. We should give that as an extra credit opportunity. If you want to Google, come in tomorrow and explain to us why it's 1.5 IQRs that we're willing to go out to establish our boundaries. We'll give you a little extra credit, okay, to the first person who does it. So what I do then is I take this 41.25, and notice I subtracted it from Q1. I'm trying to find how far below Q1 is that lower boundary. And I got negative 26.25. Do you see any commuters who take less than negative 26.25 minutes to get to work? No outliers, right? Okay. But when we add it to Q3, we get 83.75. Do you see any commuters that take more than 83.75 minutes to get to work? Yeah, that oddball, right? That guy that's commuting and taking 85 minutes. He's an outlier, okay? Now, what's important when you're asked to determine now if there are outliers present in a distribution? It's important that you now use this rule. We don't just eyeball now, we know how to calculate it. So we're expected to do that. What you need to show on paper for a free response question to get that essentially correct is all this arithmetic, okay? So let me just demonstrate it here in whatever space I can find, what I would show on paper to get an essentially correct response. I would, and you have to apologize, my writing's not always the greatest on this screen. I'd take my Q3 minus Q1. I showed that on the previous page, okay? 27.5. Multiply by 1.5, and I get that amount, that distance, the number of minutes that I'm willing to go out from the edges of my box and my box plot. No more than 41.25. So anything that's more than that is considered unusual. So then I subtract it from Q1. So I take that 15 minus that 41.25, and of course I got that negative value. That's my lower boundary. Anything that's below it is an outlier, and of course we didn't have any down there. But I also take that 41.25 and I add it to Q3. Notice I never use the median. That's the biggest mistake students make, and then they kick themselves. And I get an upper boundary. So here are my boundaries. The question is, do I have any outliers? And so at this point, I'd say 85 is an outlier, and that would be an essentially correct response, because my work supports that decision that I do, in fact, have an outlier. Okay? Pretty simple? All right, one more thing. What? Still not used to these times. All right, one more thing. We now know how to find Q1, how to find Q2, how to find Q3. And we're going to use those to make our box plot. It's also referred to as a box and whisker plot. The other two values that Lilia remembered for us was the min and the max. Those are the other two numbers that make up the 5-number summary. Now, keep in mind, a box plot has some very strong limitations. When you make a box plot, all you see is min, Q1, Q2, Q3, and max. You can see shape, you can see outliers using the kind of box plot we'll use. You can see center, at least the median, and estimate where the mean would be. You can see spread, but what can't you see if all there is that 5-number summary? Any of the numbers. You can't see any of the data. All you see are these summary statistics. Now that doesn't make it a bad plot. It just is a limited plot. Sometimes it's all you need to see those 5 numbers to be able to answer a question that you're asked. But often you're more interested in the individual pieces of data. That's when you turn to your stem plot and your dot plot, okay? Because they do show you the pieces of data and their values, okay? So if I go back to commuters, what I'm going to do, and I'll just talk. Oh, darn, I hate it that I can't animate it on here. We already identified our Q1, our Q2, and our Q3. You can see the min and the max is 25. Now, the type of box plot we make is going to be one where the ends of the whiskers will not necessarily go all the way to the max or all the way to the min. The whiskers in what's called a modified box plot go all the way to the highest observation that is not an outlier and all the way to the lowest observation that is not an outlier. You put a little dot or star or asterisk or some symbol that's separate from the whisker to show the location of an outlier. So the big difference is this upper whisker, in our case here, is not going to go all the way to 85. Because 85 is the maximum, but it's not the biggest that's not an outlier. The biggest that's not an outlier is 65, okay? So when I go to make this, what I typically do is I draw my box, okay? So let me do this on here since I am recording. So and this did not copy very well, so let me see if I can get it. All right, I'll just use this blank space here. So we had min was 5. We had Q1 was, help me out, remind me there. 15, thank you. Q2, 22.5, right? Q3, 42.5. And max is 65 with an outlier at 85, correct?
Yep.
Okay. So what I have to do, like every other graph, is I have to have a scale. So I'm going to start at maybe like 0 and count by tens. 20, 30, 40, 50, 60, 70, 80, 90. It's okay if you don't number every line. It's clear I'm counting by tens, okay? What else do I want to put on here before I forget? Title, yeah. So I'll just call it travel time for 20 New York City commuters. Okay? All right. I typically draw my box first, and that's the quartiles right here. They make up the box. So I've got the left edge of the box here at 15 minutes, the right edge of the box here at 42 and a half. I'm just estimating. So the Q1 and Q3, there's the middle 50% of my data. Okay? Within the box then, I put a vertical line where I see my median. So 22 and a half would probably be, what about right there? Okay? Emily?
Is the left of your box at 10?
Yeah.
Oh, did I put it at 10? Sorry. Hang on. I can erase that. Thank you, Emily, for noticing that. Okay. Excellent. Okay. Better? All right. Now, there were no outliers on the lower end, so my lowest value of 5 is my left end of my whisker, which I just draw in a vertical line and attach to Q1, the left side of the box. But the right side of my, right end of my data, I'm going to make my whisker go to 65. So 50, 65. Connect it to the edge of the box. And then show the outlier as a separate entity all by itself, up here at 85. Some sort of a mark. That's what's called a modified box plot. And that's a much clearer picture of the distribution of travel times for these New York City commuters. Because I can now say, all right, the box makes up all of the regulars, all the fairly typical or normal people. This guy is unusual, so let's show him as such, an unusual commuter. Okay? So when you go to describe, you want to describe the fact that in this distribution, from the center to the right edge of the tail is a little further than from the center to the left tail. So it is skewed to the right, with a median at 22.5, spread from, up to this point we've described range, we'd say from 5 to 65 with an outlier at 85. That's the most descriptive way to go about explaining what this distribution looks like. Okay?